Okay, welcome back to class. So in this class, today we are going to discuss quotient rule. Quotient rule. So quotient rule. So in the last class, if you haven't watched my tutorial on product rule, so just check my channel. So it's the previous class, the class that precedes this. So this class we're going to discuss quotient rule. So in the last class we discussed how do you differentiate a function whereby it's a product of another two functions. So, but in this class, we're going to discuss a function whereby if y equals to u over v, so where u is a function of x and v is also a function of x. So where you have, if y equals to u over v, that is, we have something like a fraction. So if you have a function that is a fraction, so then how do you differentiate something like this? So then the y dx, the rule says that, quotient rule says that the y dx equals to v, you pick the denominator, v du dx. So notice the difference between this and the product rule. So in the product rule, you can pick any of the function first. So but in the quotient rule, you pick the v first, the denominator. So v du dx minus u dv dx all over v squared. So that is the rule for quotient rule. That is the rule for quotient rule. V du dx minus u dv dx all over v squared. So an example of this is y equals x over x plus 1. Y equals x over x plus 1. So how do you differentiate this? This is our u and this is our v. So in this case, it means that to apply this rule, you pick v. V is x plus 1. V is x plus 1. Don't confuse this. This is our u and this is our v is x plus 1. So that means x plus 1 v du dx. What is our u? 1. Differentiate x. Sorry, our u is x. Differentiate x. The derivative of x is what? 1 times 1 minus u. What is your u? X. Dv dx. What is our v? X plus 1. So differentiate x plus 1. So derivative of x is what? 1 plus derivative of 1 is what? 0. That means this is just times 1 all over v, which is x plus 1, everything squared. X plus 1, everything squared. So from there now, it implies the y dx equals, so 1 times all of this, we still have our x plus 1 minus x times 1, that's x, all over x plus 1, everything squared. So we have x plus 1 minus x. So from what we have here, we have x plus 1 minus x, x plus 1 minus x, all over x plus 1, everything squared. So then what you have from here equals, so we have x minus x, that's 0. So x minus x is 0, right? So then we have only 1 is left over x plus 1 squared. X plus 1 squared. So that is the derivative of that, x over x plus 1. So let's solve another question. Second example, we have y equals x squared all over x plus 3. X squared all over x plus 3. So to use quotient rule says that, remember quotient rule, v du dx, you pick the one at the denominator first, you differentiate the u minus u dv dx minus u dv dx all over v squared. So from what we have here now, x squared is our u, x plus 3 is our v. So pick your v. Your v is x plus 3 du dx, differentiate x squared. Derivative of x squared, bring 2 here. Derivative of x squared is what? 2x times 2x plus, sorry, minus u. What's our u? X squared dv differentiate denominator. So the derivative of x is what? 1. Derivative of 3 is what? 0. So that is x squared times what? 1. All over v squared. These are v, which is x plus 3 everything squared. X plus 3 everything squared. So from what we have here, this is equals to, so then we have 2x from here, 2x into bracket x plus 3 minus x squared times 1, x squared, all over x plus 3 squared. So from what we have here now, you use this 2x to open the bracket. 2x times x, that's what? 2x squared plus 2x times 3, that's 6x, minus x squared, all over x plus 3 everything squared, which will be equal to, so from here now, 2x squared minus x squared, that's what? X squared plus 6x, right? All over x plus 3 everything squared. X plus 3 everything squared. So that is that about that. So, but from what we have here, okay, there's nothing we can do about it. I thought there's something we can do. Okay, we leave it like this. Actually, as I'll leave it. So you can leave it like that, or if you like, expand the one that we have in the denominator. So that's another example. So let's solve one more example. Y equals 1 all over x squared plus 4. 1 all over x squared plus 4. So remember our quotient rule. Quotient rule says that is what? V du dx, pick here, differentiate this, minus u, pick this, differentiate this, dv dx, all over v squared. So then from here now, this is our u, this is our v. So from what we have here now, bring this v, right? Our v is what? X squared plus 4 into bracket, differentiate 1. Derivative of 1 is what? 0. Minus our u. What is our u? 1 times, or into bracket, anyhow. Differentiate all we have in the denominator. Derivative of x squared, that's what? 2x. Plus derivative of 4 is what? 0. So plus 0. Okay, just leave it like that. All over v. Our v is x squared plus 4. Squared everything squared. So implies dy dx equals, so 0 times everything that we have here is 0. 0 times everything is 0. So 0 minus 1 times 2x. 2x plus 0 is 2x. 1 times 2x. So this is what we have 1 times 2x plus 0. That's 2x, right? Because 1 times 2x is 2x plus 0. That's 2x. All over x squared plus 4 everything squared. So this implies that dy dx equals 0 minus 2x, that's what? Minus 2x, all over x squared plus 4 everything what? Squared. That is the derivative of this, minus 2x all over everything squared. Minus 2x all over everything. So this is where we'll stop today's class on quotient rule. So by tomorrow we'll continue on quotient rule. I'll see you tomorrow.